Hello, my dear friends. Buckle up, because we're about to embark on a mind-bending journey into the very fabric of reality. We're going to wrestle with the question, is time an illusion? It's a query that has plagued philosophers for millennia and continues to fascinate scientists today. Prepare for a ride that will challenge your perceptions and leave you wondering about the nature of existence itself. This isn't just an academic exercise. It's about questioning the very framework through which we experience the world. Let's start by acknowledging the common sense understanding of time. We experience it as a linear progression, a constant flow from past to present to future. We see clocks ticking, seasons changing, and our own bodies aging. This seemingly irrefutable experience of time forms the bedrock of our daily lives and the very structure of our societies. It's how we plan, remember, and understand causality. But what if this seemingly solid foundation is built on sand? The philosophical playground, where time gets skewered. Philosophical arguments questioning the reality of time have been around for centuries, stemming from the ancient Greeks and continuing to this day. Many of these arguments revolve around the nature of change and our subjective experience. Parmenides and the immutability of being. One of the earliest challenges came from the pre-Socratic philosopher Parmenides. He argued that change is an illusion, as being is eternal and unchanging. If change is an illusion, then time, which is inextricably linked to change, must also be an illusion. This line of thought suggests that the past, present, and future are all part of a single, timeless, and unchanging now. It's a radical idea that paints our linear experience of time as a trick of perception. Zeno's paradoxes, stumbling blocks for time. Zeno of Elea, a student of Parmenides, further challenged our understanding of time and motion with his famous paradoxes. Achilles and the tortoise, the dichotomy, and the arrow paradoxes, those seemingly simple thought experiments, demonstrate the logical difficulties of dividing motion and time into infinitely small units. These paradoxes can be interpreted as demonstrating the limitations of our understanding of time and space, potentially hinting at a different framework beyond our intuitive grasp. The question becomes, are our mathematical models capturing the truth of reality, or merely our subjective understanding of it? The block universe theory, all of time simultaneously, a more modern philosophical concept, often linked to Einstein's theory of relativity, which we'll get to soon, is the block universe theory. This viewpoint suggests that the past, present, and future are all equally real and exist simultaneously. They are just different slices of a single four-dimensional block of space-time. Our perception of the present as special is then just a quirk of our consciousness, like a spotlight moving along a film strip. The future already exists, just as the past still exists. There's no flow of time, no inherent now that is more real than any other. Kant and the limits of experience. Immanuel Kant took a different approach, arguing that time and space are not objective features of reality, but rather categories of our understanding. He believed these are forms of intuition, filters through which we perceive the world. Time, in Kant's view, is a pre-existing structure in our minds that allows us to organize our experiences, but this doesn't necessarily mean it exists as an independent entity out there in the world. This means that while time is fundamental to how we make sense of the world, its existence as an objective truth is not guaranteed. These philosophical arguments, while lacking scientific proof in the traditional sense, serve as crucial thought experiments that challenge our fundamental assumptions about reality. They encourage us to ask difficult questions and consider that the reality we perceive may be far different from the underlying truth. The scientific frontier, where time gets bent, science, often seen as the antithesis of philosophy, has also brought about groundbreaking discoveries that have further muddied the waters of time. Einstein's relativity. Time is relative, not absolute. Albert Einstein's theory of relativity, both special and general, revolutionized our understanding of time and space. Special relativity showed that time is not absolute, but is relative to the observer's frame of reference. The faster you move relative to another observer, the slower time passes for you relative to them. This is not a theoretical concept. It has been experimentally verified with atomic clocks. General relativity goes even further, showing that gravity also affects time. The stronger the gravitational field, the slower time passes. This means time runs slower near a black hole than on the surface of the Earth. These findings shattered the Newtonian idea of absolute time and space, introducing a flexible, intertwined space-time. This relativity challenges our perception of a universal, uniformly flowing time. Quantum mechanics, time's fuzzy edges. Quantum mechanics, the theory that governs the behavior of matter at the atomic and subatomic level, introduces another layer of complexity. Some interpretations of quantum mechanics suggest that the past, present, and future are not as definite as we perceive them. For example, the phenomenon of quantum entanglement suggests that particles can be connected in such a way that their states are instantaneously correlated, even when separated by vast distances. Some physicists suggest that this instantaneous connection might imply that time as we know it does not exist at the quantum level. The very idea of a linear progression of time becomes blurry when you delve into the weird and wonderful world of quantum mechanics. Loop quantum gravity and the search for a theory of everything, the search for a unified theory of physics, a theory of everything that combines general relativity and quantum mechanics, has led some physicists to explore radical ideas about the nature of space-time. Loop quantum gravity, for example, suggests that space and time are not smooth and continuous, but quantized, existing in discrete chunks at the Planck scale, an incredibly small unit of measurement. This implies that time may not be a fundamental property of the universe, but emerges from these fundamental quanta. It's akin to discovering that water, which appears smooth, is actually made up of discrete molecules. The problem of time in quantum cosmology, when we attempt to apply quantum mechanics to the entire universe, to study the very beginning of time and space, we run into the problem of time. In general relativity, time emerges alongside space as part of the fabric of space-time. In quantum mechanics, however, time is often treated as an external parameter. The two approaches don't mesh, suggesting that we still have much to learn about the nature of time at the cosmological scale. Some theories suggest that time, as we experience it, might simply not exist at the quantum level of the universe as a whole. So, is time an illusion? The verdict is complicated. After this whirlwind tour of philosophy and science, it's clear that the question of whether time is an illusion is far from settled. There is no single, universally accepted answer. Here's what we can conclude. Time as we experience it is subjective. Our everyday experience of time as a linear progression may be a subjective interpretation of a deeper, more complex reality. Our perception of a present now might be a result of the way our brains process information, rather than an objective feature of the universe. Time is not universal or absolute. Einstein's relativity has definitively shown that time is relative, not absolute. It is malleable, affected by motion and gravity. This challenges the traditional idea of a single, universal clock ticking away for everyone and everything. Science is pushing the boundaries of our understanding. Quantum mechanics and attempts at creating a theory of everything are forcing us to rethink the very nature of time and space. The possibility that time may emerge from more fundamental properties of the universe, or may not exist at all at the deepest levels of reality, is a compelling, albeit perplexing, idea. The importance of the question, even if we can't definitively prove time is an illusion, The journey of exploring this question is incredibly valuable. It pushes us to question our assumptions about reality and challenges us to look beyond our everyday experiences. It reminds us that our understanding of the universe is constantly evolving and that what we perceive as reality may be only a small part of the bigger picture. Ultimately, the debate about whether time is an illusion continues to spark fascinating discussions and motivates cutting-edge research. Whether it's a fundamental aspect of the universe or a convenient construct of our minds, time is undeniably intertwined with the very fabric of our existence. Perhaps the true answer lies not in whether time is real or an illusion, but in understanding the nature of the observer and the complex interplay between consciousness and the universe. So, keep questioning, keep exploring, and embrace the mind-bending beauty of this profound mystery.